Everyone, I am your first reporter for today, Dali May Bongka, and the second reporter will be Mr. Lloyd Chester Barber. So our topic is all about introduction of cloud physics. So our outline will be general aspect of clouds, cloud formation, type of clouds, and growth and distribution. So cloud physics is the study of physical processes that lead to the formation of growth and precipitation. Clouds are composed of microscopic droplets of water, tiny crystal of ice, or both. Under the suitable condition, the droplets combine to form a precipitation where they may fall to the earth. So, basically, cloud physics is the study of physical processes that lead to the formation of growth and the precipitation of the atmospheric cloud. So, cloud consists of microscopic droplets, yes. So, the water, the tiny crystal of ice, and both. So, water will be represented by the warm cloud, and the tiny crystal of ice will be represented with the cold cloud, and pwede din siya both. So, we will be going to discuss it later. So, cloud is defined as a visible aggregate of minute particles of water or ice or both in the free air. So, cloud form in the sky and develop and take different shapes and dissolve. So, each process is an indication of some physical state of process in the atmosphere. So, we also need cloud because, as we all know, cloud protect, ginaprotektahan po ta sa cloud para maprotektahan po ta sa kuan sa sun, and naga-provide po siya of water or rain na makatabang po siya o sa ato ang environment. So, we have a cloud formation. So, cloud formation when water vapor in the atmosphere condense to form a very small liquid water droplets or a ice crystals. So, the cloud formation. So, the cloud formation process usually begins when the heat from the sun warms the ground. These cause the air at the ground level to rise and the water vapor within it to cool. When cooled, the water vapor collides with the strikes to the tiny particles floating in the air, which became dust and salty, and became that form to become a cloud. So, we have four types of clouds, the cloud formation. So, we have pre-convection, topography, and level convection, and front convection. So, pre-convection is a process of the sun radiation strike the ground heating. So, as the ground temperature warms, it hits the layer of air directly above its through conduction. So, the transfer of heat from one substance to another, because barren surface like sand rocks and pavement, becomes warmer faster than the ground covered by the water or air at the near surface. As a result, some pockets warm faster than the others. So, the faster warming pockets become less dense than the cooler air that surrounds them, and they begin to rise. The stronger the surface heating, the stronger and the higher up into the atmosphere and the convection extends. So this is why the convection is especially active on the hot summer afternoon. So we have the next is the topography. So topography is a um, it is lifted up and over the mountain. So as shown in the diagram, wind wind pressure against a mountain barrier force air to rise on the mountain's windward side. As the rise it cools to the dew point cloud form and rain from may fall on the leeward side of the mountain. So, um, ang moist na gikan sa na nagadirect siya gikan sa mountain, nagarise siya up, tapos naga-form siya og og cloud. Mao na siya nagapa-form og cloud. So mao na siya tong mga makita sa kanang bundok gud nga duol kayo ang cloud. So example ana is kanang naga-fog gud siya, mao na siya ang naga-cause na mahimo siya og cloud. So next is the low level convection. So ang parehas lang din siya sa free convection. Ang pinagkaiba lang nilang dalawa is ang low level convection kay naga meet together sila, tapos nalang naga they kanang one lang yun sila ba to form a cloud. Then the more nga naga kuan sila together, the more maupod na siya ang makakos o nga mubugat ang isa ka cloud and naga-form siya og rain. So next is the fronts. So fronts mark the boundary of the large air masses dragged into the contract of mid-latitude cyclone. So the warm and cold fronts are particularly interesting and important lifting force. So we also consider the phenomena in the next two sections, beginning with the explanation of air. So front is formed by the cold air and also a warm air. So once the air has risen, it cools and the clouds can be formed. So next is a type of clouds. So clouds formed in nature can be grouped into different categories depending on the process by which they develop. So we have two types of process by which clouds form. The warm clouds and the cold clouds. So warm clouds consist entirely of droplets which have been formed by the condensation into aerosol particles. So aerosol particles respond to changes in humidity in different ways depending on their chemical composition and solubility. So particles which are soluble and hydrophilic um, take on water as humidity increases and increases in size. Above a certain relate, relative humidity is soluble particles will be liquids. The solid particles dissolve in the water and it has taken on and becomes a tiny liquid drop but not yet a cloud drop. So, warm cloud characteristics is cloud tops below the freezing level. So, and the composition is consist of water droplets. Then the particles radius would be 0.01 mm and main process is collusion. So few large drops form, then the cloud grows. So we have a cold cloud. So cold clouds are defined as those clouds with tops colder than 0 degree. So this, ang naadiri sa top is the ice crystals that grows by the deposition of freezing of super cool water. Growths continue by the rhyming aggregation and deposition. So kining linya na naadiri sa 0 degree Celsius pataas is the cloud, the cold cloud. And pababa diri hangtod sa surface kay mao na siya ang warm clouds na nagaproduce of raindrops. So we have also a characteristics of cold clouds na cloud tops above freezing level. So kining top ani ang warm clouds na nagaproduce of raindrops. So we have also a characteristics of cold clouds na cloud tops above freezing level. So kining top ani the freezing level that forms ice or crystals and super cold water droplets. Then the particles radius is 0.25 mm. Main process is Bergeron process na explained by Mr. Barber. And ice crystals grow at expense of cloud droplets. So we also have cold cloud, that cloud extending above the 0 degree isotherm, and the super cold droplets, the water droplets at the temperature of 0 degrees Celsius, and the mixed cloud. The cloud consists of the both ice particles and the super cold droplets, and the day-shaded cloud consisting of ice.
Blue spiky lines, red bumpy lines, we see these on our weather maps all the time. But what are these fronts, and what do they mean for our weather? As the atmosphere flows around the planet, it tends to do so in large air masses, each of which has fairly uniform conditions of temperature and humidity. It's at the boundaries between these air masses that we find weather fronts. If a cold, dry air mass pushes into a warm, humid air mass, we have a cold front. And as the colder, denser air advances, it forms a steep wedge that forces the warm air in its path upward very quickly. Clouds form right at the front. This typically produces very abrupt, sometimes very intense active weather. If a warm, humid air mass pushes into a cool, drier air mass, we have a warm front. With warm air overtaking cooler, denser air, the warm air is forced upward but at a much gentler slope than with a cold front. This produces widespread cloud and precipitation along the front and just ahead of it, and as the warm, humid air flows further up that gentle slope, it results in mid-level clouds ahead of the active weather, cirrus clouds far out in front. We don't necessarily need moving air masses though. If there is an abrupt boundary between two air masses, but neither is intruding into the other's space, we have a stationary front. This can result in the same kind of weather associated with a warm front, but which can last for much longer, sometimes for days at a time. And finally, there's the case of the occluded front, where the fronts themselves push into one another as a fast-moving cold front overtakes a slower-moving warm front. As the two fronts meet, the warm air between them is pushed upward, but the denser air behind the cold front also wedges the cool air ahead of the warm front upwards too, lifting the entire boundary between cool and warm air completely off the ground. Due to the combo of cold front and warm front conditions, this often results in a combination of the weather from both as well, producing active, sometimes severe weather along the occlusion. So this wraps up Season 1, as we've gone through all the basics of weather, from why we have it, to the individual components and how they come together to produce our active weather. In Season 2, we're going to focus in on the action to talk about thunderstorms, lightning, tornadoes, hurricanes, and other extremes as we all become a bit more weather-wise.
Then, in mixed cloud, equilibrium vapor pressure over ice is less than that over water at same temperature. Therefore, ice crystal grows by deposition of vapor provided by the evaporation of water droplets. So, ice crystals can also grow by the colliding with supercooled droplets, which freeze into their accretion. So, cloud formation. So, cloud formation, as we all know, is an air parcels rise, cool and condense. In warm clouds, droplets can grow by the condensation. In a super-saturated environment and colliding with other cloud droplets. So, cloud droplets can also form with aid of cloud condensation nuclei in an unsaturated environment. The water droplets can exist in cloud as supercooled droplets, even below 0 degrees Celsius. So, cloud temperatures frequently need to be below 10 degrees Celsius for any significant number of ice particles to form. And maiwasan po itong freezing rain na nag-occur siya when the layer of the freezing air is thin. The raindrops do not have enough time to freeze before reaching the ground. Therefore, the water freezes on contact in the surface na may mo na siyang raindrop. So, mao to siya katong ice tungod sa thin ang freezing air, mao to siya ang nahimong ice na nagaulan og ice. So, kailangan dyan siya nga 10 degrees Celsius ang temperature sa cloud. So, cloud containing both ice particles and supercooled droplets, mixed cloud. So, condensation acts to slow to produce rain. Several days required for condensation cloud rain in less than 1 hour. So, next is we have a growth of cloud droplets. So, ordinary cloud droplets are extremely small, average size. So, if the cloud droplet is equilibrium with its surrounding, the size of the droplet does not change because of the water molecules condensing into one droplet will be exactly balanced by those evaporation. And if it is not equilibrium, the droplet size will either increase or decrease depending on the weather condition or the evaporation predominates. So the next topic would be mechanism of growth of cloud droplets, the condensation, illusion, and the Bergeron process. Now, matopic ni Mr. Barber. So, that would be all. Thank you.